Last class we have seen about wired media or guided media, okay, or communication happening through physical media. Okay, in this section we are going to see the wireless media or wireless networks. Okay, so which are the wireless networks and what is the purpose of wireless communication, or how actually the wireless communication works. Wireless communication uses radio waves, microwaves, satellites, and other short frequency waves like infrared and Bluetooth, Wi-Fi, etc. Okay, so a wireless network which uses high frequency radio waves rather than wires to communicate between nodes is another option for home or business networking. Okay, it also provides mobility and it also overcomes the physical disturbances or physical improbabilities like the cost of digging areas to place the wires or placing these wires entirely in a complex manner. These kind of difficulties can be overcome using wireless networks. Wireless networks allow sharing of devices without any networking cable, which increases the mobility but decreases the range. There are two main type of wireless networking: peer-to-peer and ad hoc infrastructure. Okay, that are the two type of wireless networking: peer-to-peer and ad hoc infrastructure. Okay, so nowadays wireless networks are becoming very popular. They use electromagnetic waves to communication. Okay, so we are going to see each one in detail. First, we are going to see radio waves. Okay, so radio communication uses radio frequencies in the range of 3 kHz to 3 GHz. Signals are modulated on high-speed radio waves, then transmitted using that technology like amplitude modulation, frequency modulation, phase modulation, etc., which you have already studied in physics classes. Okay, so it can be used in both indoors and outdoors because it penetrates through physical objects like buildings, buildings, etc. Okay, so these waves can be easily generated and can travel long distances, and it can also penetrate buildings very easily. So that's why it is used in both indoors and outdoors, and it also offers mobility. Okay, then main feature is that radio waves are omnidirectional, which means that once it is propagated, it can be propagated into all directions, not a point-to-point communication or a line-of-sight communication. The signal generated from the antenna can be spread across multiple directions or in all directions. So the receiver and sender does not need to be on the same direction or does not to be on a line of sight. Okay, then radio waves are cheaper than guided methods. So as you can imagine, laying cables underground and etc., which makes it is very expensive, and it is also very expensive compared to other medias. Okay, so then it is also unsecure. It's which is a drawback of this radio communication, which is expensive and unsecure, and it is prone to weather effects. As you know that in the case of our mobile communication or etc., when there is heavy rain or heavy weather effects are there, our communication becomes very less susceptible. Okay, and then complexity in establishing. Okay, so to establish this radio communication, we need to get proper permission from the concerned authorities like government offices. Okay, so there is complexity in establishing. So these are the main features of this radio waves. Okay, so as an example, we can see both indoor and outdoor cordless phones, AM and FM radio stations, then garage door openers, etc. These are some examples of radio wave transmission. Next, we are going to see microwaves. Okay, so compared to radio waves, microwaves are line of sight transmission. Both antenna and receiver must have to be in the line of sight. Okay, so as signals travels in a straight line only. Okay, so in microwave communication, two directional parabolic antennas are used. Okay, so one side will receive the signal and other side will send the signal. So it acts as a repeaters. So microwave antennas works as and receivers and repeaters at the same time. From one side it will receive and at the next side it will transmit the signal. Okay, so they can be mounted on towers, buildings or hills to send or receive signals through air. So it has to be properly aligned, otherwise the signal will be lost. Okay, then easy over difficult terrains. Okay, so if the terrain or our area is very difficult to reach or anything like that, then it is easy to be on the difficult terrains. And then transmission rate is 16 gigabits per second. Like radio waves, it is also an unsecured communication. And then if the radio receivers, not radio receivers, microwave receivers and antennas are not aligned properly, then signals can be split and propagated among different directions, thereby reducing the signal quality. Then it can be also be affected by weather conditions. And then cost of installation is very high. So these are some disadvantages of microwave propagation system. Okay, next we are going to see infrared waves. Okay, so infrared waves are short range. Okay, they provide communication up to a short range of 5 meters. Then it operates in the frequency range of 300 gigahertz to 400 terahertz. Okay, so the infrared transmission technology used in computers are similar to the technology used in TV remotes and toys, etc. Okay, so it is also a line of sight transmission. So it cannot penetrate through physical objects like walls and very hard objects like metals, etc. So it is a line of sight transmission. Then it does not need any licensing process, etc. like that. Then these waves are easy to build and have a major drawback: they do not pass through solid objects. Okay, so as an example we can see, if a person stands between you and your TV, then if you operate on your TV remote, then the channels will not be changed. Like that, it does not pass through any kind of physical objects. Then another drawback is that it allows only 2 devices at a time to connect between each other. Okay, then performance drop with the increase in range. When the range increases or when the distance increases, there is a performance drop is there. Okay, so this is basic idea about infrared waves. Then next type of wireless method is that Bluetooth. Okay, which we are all familiar about. Okay, so Bluetooth is mainly used for PAN, personal area networks within 10 meter range. It uses a 2.4 gigahertz unlicensed channel. It's an unlicensed channel, so everybody can use who having a Bluetooth receiver and a transmitter. Then anyone can access that particular band. Then it consumes lesser power. Okay, less power consumption is the main feature of Bluetooth. Okay, then it works only on a short range, as you can identify that when we are transmitting using our phones, when we are transmitting our files through Bluetooth, you can identify that only a short distance is permitted there, and the speed of the transmission or transmission rate is very slow. Even if it is a smaller file, it will take some time to send the data. Okay, so that is the specialty of Bluetooth. And another specialty is that it can connect up to 8 devices at a time. Okay, based on the Bluetooth technology, you can connect up to 8 devices simultaneously. Then another method which is similar to Bluetooth is that Wi-Fi. Okay, which you are already familiar of. Wi-Fi or wireless fidelity communication is similar to Bluetooth in operation, but can cover a larger range than Bluetooth. Okay, it allows mobility and mainly it is used for internet connectivity. Okay, so because of it is used for internet connectivity, it offers high speed communication. Okay, so that is all about Wi-Fi and Bluetooth. The last one we are going to see is the satellite link. Okay, so most effective communication at the time, it is most expensive communication also. The satellite communication uses the microwave signals as media. Okay, so it uses the range of frequency range of 1.5 gigahertz to 20 gigahertz. Okay, so most common examples are DTH, direct to home service, VSAT, GPS, then satellite phones, etc. are the examples. Okay, so as you have learned in the previous classes, there's two type of satellites are there, geostationary and polar satellites. So based on this position of the satellite over our earth, then it uses to establish communication using various earth based stations, and having these stations will have antennas to receive and transmit signals. Okay, so every satellite works as a trans-receiver antenna. What's a trans-receiver antenna? A trans-receiver antenna is a type of antenna which receives and regenerates or amplifies the signal which it received by them, and then again redirect the signal to another location or the same location where the signal is received. So a trans-receiver, a satellite works as a trans-receiver which receives the signal, regenerates or amplifies the signal, and then redirect the signal back. Okay, so that is the specialty of a satellite. Then it covers a large area. Compared to other wireless media, it covers a very large area. Then it is secure and uninterrupted. There is no interruption during the transmission, and then it is also secure and high quality. There is no line of sight restrictions are there. Okay, so compared to microwave or other line of sight communications, there is no line of sight restrictions such as natural mountains or tall buildings or towers or something like that. Okay, then compared to other medias, it is very expensive and involves high operating cost. So you know that when we launch a satellite, if you have to launch a satellite or etc. like that, it need heavy money to work in the satellite communication. So it involves high operating cost. Then it is slower than microwave communication. So microwave communication works in the terrain of earth itself. So line of sight communication, thus it is faster. But the satellite communication works, the satellite will be in outer space, and the receivers and transmitters in the earth based receiver system will be on the ground. So there is a loss of signal strength. So it is slow compared to microwave transmission. Then it need heavy legal permissions to work, and then installation is very costly and very complex. And then signals can sent to this station can be interrupted by external interferences. Okay, so the signal is coming from the outer space itself, and we are sending the signals to the outer space. So satellite works on a trans receiver there. So there will be interference in the path of transmission. So there is a very large chance of interruption or external interference. So these are all about this wired and wireless transmission. With these two parts, you can see that the wired and wireless communications are over. Then next class we will see on another topic.